Hello, everybody. How are you all doing? I hope you all are doing well and good. So, we all have learned about 8051 microcontrollers and 8085 microprocessors during our fourth or fifth or sixth semester, right? Based on whatever course you are learning right now, computer engineering, EC, or electrical, or IT, in most of the cases you learn these microprocessors and their programming 8085 and 8051. But because of the lack of the equipment, we have so many students who do not get to perform the practicals online or on the kit. But what if I tell you there is a way, an alternate arrangement that can help you to learn the programming of 8085 or 8051? Right, I'm talking about a website or a portal which acts as a playground of 8085. It's an online simple website which is available for all of us for free of cost, and you can simply go there and you can run whatever program you want to learn, whatever program you want to run, and whatever you want to do, you can do that. So एक ऐसे ही प्रोग्राम के बारे में हम लोग डिस्कस करने वाले हैं आज. सो लेट्स सी व्हाट इज दैट प्रोग्राम. सो लेट्स कम हियर, लेट्स सी. So just go to your browser and type sim 8085, right? In Google just type sim 8085, and the first link, this one, sim 8085, will lead you to this console. Okay, so this is a 8085 microprocessor playground which allows you to simulate whatever code you want to run, allows you to learn the basics of microprocessor without having the kit of 8085 on hand. So it is very handy. Plus जब भी आप यहाँ पे वेबसाइट पे पहली बार आओगे, it will give you a tour, it will tell you what section is what. Like see, it is telling you this is code editor and its operation. You can enter your ASM code, and then it gives you a note if you are using the below boilerplate code written. Write your code after the start label, and otherwise it will not execute, right? Then you can next learn about other things. We have the compile button. I have already learned about their applications, so I'm skipping them, but you can learn about it. Okay, so on this console you can run whatever program you want to write in this white space. This uh, this file is named as main.asm, as you can see. So I can write whatever I want to write in it. I can simply cut, copy, paste the way I want to, just like we do it in any other editor. On the right hand side you can see the memory view. So if you all are aware about it, then in 8085 microprocessor you can go from memory location 0000h. It operates in a hexadecimal. Okay, it operates in a hexadecimal numbering system. It follows the hexadecimal numbering system. So you can go from 0000h to FFFFH, right? From 0000 to you can go to FFFF. See, on the left hand side it is showing you the address, and on the columns you can see the address is here. See, FFF, it's going from 0 to F, right? FFFF, and it's going everywhere. You can see the zeros here. That means there is no value entered here yet. Yeah, right. There is no value which has been entered here yet. So that means there is no value assigned to these memory locations yet, right? And you can move forward and see that as well, right? Okay, sorry. See, right. Let's move to some other memory location. Let's say 0000. Okay, and then I can move using this scroller, or I can enter my memory location wherever I want to go using this. See, right now it's showing me 0000, so this is 00000001 is this is 0002, and so on. You can go till 000 00ff, and as I scroll this one, it gives me the values. See, 0d0, 0df, 10df, and so on. You can go, right? You can take the start address from here as well. If I want to check from 2200, then it will give me 2200. If I want to go 0 back, it gives you that. And you can move from here as well, like say I'm entering 2000 here. Okay, so it will give me memory location 2000. So that also does. Remember, microprocessor 8085 holds the values from 0000 in hexadecimal till FFFF in hexadecimal. Okay, and whatever value or whatever instruction you will enter, it will be loaded at, see here they have written it here, 0 cross 800. Okay, so program counter will load it over there. This is the compile button. You can write the program and compile it, assemble and load your program. This is the run button. This button will run all the instructions which you have written together, all at one. Okay, every instructions, all the instructions will be executed at once. And this one, you can execute every single instruction one by one. Okay, first, instruction by instruction, you can execute the instruction. So that what happens, sometimes you want to check that I want to enter the value 202 into memory location 2070. So what I will do, I will one by one run that command, and I will check here whether my value is present or not, right? That I can do. This is the stop button. So while your program is running, and if you want to stop your program, you can do it. After execution, you want to stop the program, you can do it using this button. This is the reset button. It will reset the values which you have allocated to particular memory location with the help of your program. So by using reset, it will reset all the values. Okay, we will see their application one by one. Let's say I want to use this application, I want to use this command lxi h comma 2000h, and then I am entering mvi m comma, let's say 02h I'm entering, and then there is hlt. Okay, so what does this lxi h comma 2000 will do? It will load the value 2000. It will load the memory address 2000 in my hl register pair. Then what will mvi m comma 02 will do? So whatever memory location is being pointed by hl register, it will assign the value 02 in that memory location, right? So what it will do, it will assign 02 into memory location 2000, and then we have halt, which will stop your program, right? HLT or halt is compulsory to write at the end of the program in 8085. This is an indication that your program has ended. There is no further instruction to be given to your program. Okay, so first what we will do, we will execute it. Okay, it is telling me that your code has been compiled and loaded to memory location 0 cross 800, and now now you need to execute your program. Okay, so now I can execute every instruction one by one, so you will be able to understand what I just did. So let's execute first one, second one, third one. So at the end of the third one, you can see in 2000 I'm getting 02. That means the value 02 has been loaded to this memory location 2000. See, right? So that is how you run the command. and after running the command you can stop your command using the stop button, just like this. Okay, now I have stopped the program, but yet I'm having value 2000 stored in, I'm having value 02 stored in the memory location 2000. So how do I uh, how do I reshuffle this, or how do I arrange it back, or how do I nullify this value or memory location? So for that I will be using reset command, and see, again we have 00 in memory location 2000. So that is why 0 reset command is used. Then we have the registers. It is telling you the value in each register. Here you have your accumulator, you have PSW, program status word, you have the register pair B and C, you have register pair D and E, and the register pair H and L. These three are 8-bit register pairs. So each register consists of 8-bit, and if you want to operate with these registers but you have to operate in 16 bits, so what you can do, you can take the register pairs together and then you can operate, right? You want to operate on a number which consists of 16 bits. So what you can do, you can take register pair BC or register pair DE or register pair HL, and then you can operate it, right? Then you have okay, and by the way, accumulator is also a 8-bit register. But accumulator is special, why? Because every single arithmetic operation that you are going to perform, most of them will be performed in the accumulator only. Okay, most of the arithmetic instructions will be executed in the accumulator only, and the result of that instruction will also be stored in the accumulator only. So accumulator is very important register here. So after accumulator and PSW, program status word, you have BC register pair, DE register pair, and HL register pair. Then you have your SP, which stands for the stack pointer, and PC, which stands for the program counter. Now both program counter and stack pointer are 16-bit registers, and they are used to hold the memory address. And their size is 16-bit because we often use them to point out memory locations. And as we all know, the memory locations are made up of 16 bits, right? We are having 4 digits here. One digit, 2 digits consist of 8 bits. That means 4 digits consist total 16 bits. Now here you have stack pointer and program counter. First let me explain you the functions of program counter, or what program counter does. So basically microprocessor uses the program counter to sequence the execution of the instructions. The function of program counter is to point the memory address from which the next byte is to be fetched. And when a byte is being fetched, the program counter is incremented by 1 to point out the next memory location, right? So for an example, primary what is the primary objective of program counter? To sequence the execution of instruction. It will make sure that your instruction, if getting executed, it will follow one particular address, or it follows particular sequence. Okay, it will make sure that. And second thing is, it will point out the memory address from which next byte is going to be fetched, right? It will point out, if my pointer is currently at memory location 2050, then next byte will be fetched from 2051. So what my program counter does, it will point out 2051. Then if I'm executing 2051, then it will point out 2052, right? So that is the work of program counter. Just like program counter, we have stack pointer as well. What does stack pointer do? So again, stack pointer is also a 16-bit register, and it is also used as a memory pointer, but it points to memory location in read write memory. It does not point out memory locations in general, it points out the memory location in read write memory, right? So this memory is called stack. And you can define the beginning of the stack by loading a 16-bit address in the stack pointer, right? And by doing that, you will be loading the value in the stack pointer. We will learn about each and every register and each and every single instruction memory location in detail in upcoming lectures. I'm planning to make a lecture series out of this, so we will be able to execute so many programs all together and learn together. So we are keeping this lecture short. Let me explain the flags and then we will wrap this. So 8085 also has flags. There are five types of flags, as you can see. We have zero flag, stands indicated by Z, S flag or sign flag indicated by S, parity flag indicated by P, carry flag indicated by C, and auxiliary carry flag indicated by AC. Okay, and all these flags are part of one single flag register, and flag register also consists of 8 bytes. And let me show you the position of all these flags in flag register. See here, see, carry is at D0 location. So basically what does carry do? Whenever you are operating in arithmetics, so if an arithmetic operation results in the carry, then cy flag will be set. And by saying cy flag will be set, I mean this carry will be uh, this carry flag will be ticked here, right? Otherwise it will be resetted or remain as it is. Then we have zero flag, which will be set to 1, or it will be ticked out when the result is 0, and otherwise it will remain unticked, unchecked, or reset. Then we have sign flag. So here you can see if this sign flag is the last one, so it will be set if the bit D7 will result of 1. Okay, if the value of this bit becomes 1, then sign flag will be activated. If not, then it will reset. What does that mean? That means my number which has been entered in that memory location is a negative number. If 1 indicates and sign flag is active, that means that number is a negative number. Then we have a parity flag, where if the result has even number of ones, then the flag will be set, which means the flag will be activated or checked. Otherwise it will remain as it is. And then we have the auxiliary carry or AC. So in arithmetic operation, when a carry is generated by digit D3, you will learn about it in detail in one of the experiments. But for now, just understand that if carry is generated by digit D3 and it is passed to the digit D4, as you can see here, then the auxiliary carry flag will be set, and this flag is used internally for BCD operations. Okay, so that was the basic of sim 8085. And from the next video onwards we are going to try programs, so you will get better idea of 8085. Till then, I'll see you next time. If you want to check out the playlist on 8085 microcontroller, sorry, microprocessor, the link will be flashing on the top right hand side corner of your screen in the I button. You can click on it and you can check out the video. And I'm planning to make it a video series, so I will be coming up with more videos related to 8085 and sim 8085 simulation tool. So make sure you check out all the videos in order to learn that. Until then, thank you very much for listening. Keep learning, and goodbye for now.